Hey guys, and welcome to day 3 of learning Web3 development. We are on a 1 week journey to create a Web3 dApp. And when I say dApp, I basically means decentralized application. And we are going to build that Web3 dApp from scratch, right? And today I'm going to introduce you to Solidity, and then we will go ahead and create our first smart contract. But before going over there, we should at least know what is a smart contract and other related terminologies, right? So first we are going to deduce all those things, and then we will jump onto the IDE and we'll try to implement a basic smart contract, and then we'll try to implement the full stack application that we are going to do, although we are not going to implement the entire full stack application today, right? We are just going to implement the backend side of it, right? That means the smart contract that is going to govern the entire logic of our decentralized application, right? But before going over there, we should know the basic terminologies. So the first thing that you should know is what is a smart contract, right? And how is it different from, let's say, a conventional contract, right? Now, this is something that you should know before diving in, right? So, a smart contract is basically a self-executing code, and that self-executing code is going to be basically executed once the predefined conditions are met. Right. Now, what these predefined conditions are, these conditions can be the agreement between two parties that are present on the blockchain, or you can say that is being deployed over the blockchain, right? So, in order to understand this, think of a vending machine. Over there, you just pay the amount, the machine verifies the amount, and if everything goes well, provides you the product or the item that you have paid for without any middleman or a cashier sitting beside it, right? There's no cashier sitting beside it who is going to accept your money and provide you the product or item that you have basically paid for, right? That all of this happens automatically, right? So just like that, smart contracts code execute automatically based on certain conditions. And when I say based on certain conditions, that basically means the conditions should satisfy the rules of agreement, right? Perfect. Now, these smart contracts are better than your conventional contract because they don't need any human intervention for execution, right? If the conditions are optimum and meeting the requirements, the agreement code written inside the smart contract will be executed automatically, right? So these contracts are immutable and foster trust, as you don't have to rely on any third party to keep up the rules of agreement, as the code that you will write will enforce the rules. All the code that you are going to write will be the source of truth. You don't have to rely on someone else. So that's why these things are called contract. They treat rules as set of agreements between two parties, right? And why they are called smart contracts? Because they can execute their code based on certain conditions automatically. You don't have to rely on any third party to enforce those rules, right? So these are basically smart contracts. And in order to create these smart contracts, obviously you need two things, right? The first thing that you would require is a programming language, right? And the programming language that we are going to see is Solidity, right? And the second thing you want is an IDE that is going to basically help you to write this Solidity logic, right? And see, I know that you guys have VS Code or let's say Cursor or any other IDE installed in your system, but we are not going to rely on a local IDE today because you have to additionally install a Solidity compiler and all that stuff over there. And I don't want to dump down all the things in one video itself. So what we are going to do, we are going to use an online IDE because that is very, what you can say, that helps you in creating smart contracts without relying on heavy resources that you have to install in your local system, right? So you can just directly go to that IDE, and that IDE is basically called as Remix, right? Okay, perfect. So Remix is your one-stop solution for everything. You can write down your Solidity smart contract code over here. You can compile it. You can basically deploy it. You can test it. It's one-stop solution, and it's best for beginners because you don't have to rely on any other resource, right? You don't have to rely on any other thing to be installed in your local environment, and you can just do things from get-go, right? You can just log into Remix and you can start everything from here only. You don't have to rely on anything else. Correct. Now, this is the ID that you are going to use, but what programming language, right? So there's a programming language which is called Solidity. You can just go right into the documentation itself, and it is basically saying Solidity is an object-oriented high-level language for implementing smart contracts. Okay, we know that because we are covering the same thing only. But how exactly you should learn it, right? And I'm going to tell you the absolute truth, guys. The thing that you should refer to learn Solidity is its documentation only, because the documentations are very, very apt, right? And they are very, very easy to understand. You don't have to worry about anything. You don't have to go to any other resource. If you have a read of this, you'll be able to understand it very easily, right? If I go to Solidity by example, right, they have given you, I guess, 4 or 5 examples that you can go through, and you can run in Remix as well to understand how these things are functioning. And if you are able to understand this, believe me, Solidity will be a piece of cake for you, right? But I'm going to show you some basic things of Solidity while we are building the what you can say smart contract that is going to be the backend, or that is going to serve as the backend of our full stack application that we want to build in this particular week. So there might be few concepts covered over there, but if you have to go deeper into Solidity and if you have to learn by your own, you should visit the official documentation. Also, in the post that I have basically mentioned some of the resources that you can refer for Solidity, right? And now let's go to Remix and let's directly jump into uh, creating our first smart contract, right? First smart contract. And the first smart contract is going to be very basic. It is going to be just a hello world contract, because why not? We just wanted to understand how exactly a Solidity syntax going to look like, right? So you don't have to worry about anything right now. What is this and what are all the folders that you can see over here? What is the folder structure? You don't have to worry about that thing, right? You are just at the very basic level of it, right? So you just have to kind of see how things are working. Don't go very deep into these things as of now, right? As of now, you don't have to worry about that. Now, what I'm going to do, I'm just going to create a folder itself, not folder, a file itself, and I'll say hello world.sol. Now, SOL is the extension, you can say, for Solidity programs. Like we have TS for TypeScript, we have JS for JavaScript, we have let's say PY for Python. Similarly, we have SOL for Solidity, right? So the first thing that you have to do over here is, right, you have to specifically mention the license identifier, and that is very, very important. Without that, your Solidity program will not run. So what you have to do, you will just say SPDX, right? And then license identifier, right? And you just have to put MIT over here. Number one thing. Second thing that you have to put is you have to specifically tell that which version of Solidity compiler your program is using right now. This is just to basically uh, help you or help the Solidity compiler to understand that this program is compatible with the version that is mentioned over here, right? So it helps you to keep your code bug free and all, right? So you can just simply say pragma Solidity, and this would suggest that I am using 0.8.0 and above, right? If you have to use something between 0.8.0 and 0.9.0, you can just simply say above 0.8.0 or less than 0.9.0. Not or, basically this is going to act as an AND condition, but we are not going to specify this. We are just going to say anything above 0.8.0 will be good enough for us, right? So I'll just say contract hello world. This is basically defining the contract, right? Now, the contract that I'm going to define is I'm going to assign a variable. I'm going to basically declare a variable and assign hello world to it. And then I will, what you can say, declare a function. I'll declare a function that can help me to update that variable's value. So these two things I'm going to do in this particular hello world contract so that you can understand these things in a very basic manner. So now Solidity is a statically typed language, right? Java in JavaScript, you don't have to mention the data type of the variables that you are declaring, but that is not going to happen in Solidity. You have to specifically mention. So I'm just going to say string public and then let's say message variable. Now public basically means that this is a public variable, or you can say this is a state variable. When you declare a variable with public, it is basically permanent, it will permanently be present over the blockchain, right? So that's why they are called state variables, because they will be responsible for the state of your blockchain, right? So let's say string public message and then you will declare a constructor. Now, constructor function over here helps you to set the initial state of the smart contract, right? So initially, what should happen? Your message should have hello world message inside it. Your message variable should have hello world message inside it. So you can set up the initial state of your smart contracts by the help of constructor function, right? Once your smart contract has been deployed over the blockchain, whatever logic you have written inside the constructor, that will be functional over there, and that is going to be the starting point of your smart contracts state, right? So you can just simply say that initial message, the value of initial message is, let's say, your hello and world, right? Perfect. Now I want to create a function that will help me to update the value of this message variable as well. So I'll just simply say function update message, right? And I'm going to call this function as public. Basically, I'm saying that this function can be called from within the same contract as well, from some other contract as well, or some other account as well. Basically, it can be called from anywhere, right? So that's why I'm setting it up to public. Okay. Now, I can just basically take a variable over here. This variable will be a parameter that is going to capture the value that you want to update inside the message variable, right? So you can just simply say a string type of message. Now, see, there is a, what you can say, there is a warning over here, and that warning basically means that whenever you are taking these kind of parameters, you have to specifically mention where exactly these things are going to be stored on the blockchain, right? So if you are using any temporary variable which is confined to this function only, right? So you can set it up to memory, that this thing is going to be stored in memory. This is just a temporary variable. I'm not going to use it anywhere else in my code, right? And this underscore basically is there to distinguish between a state variable and a temporary variable. So this is just a temporary variable. Whenever you are going to declare a temporary variable, use the memory location as memory and an underscore in front of the variable. Then you just have to do one thing, which is update the value of message to this underscore message, right? That's it. And over here, these semicolons are really important. I know in JavaScript they are not, but in Solidity they are, right? Now you can see that there are some gas and all written over here, right? Infinite gas, 331200 gas, right? What exactly is this gas, right? So guys, we should know everything about these things before diving deeper into the concept of it, right? So when I say gas, so gas basically means fuel that is required to do any kind of operation on the blockchain, right? So whatever you are doing over the blockchain, whether you are sending a cryptocurrency, whether you are sending any funds, or whether you are going to deploy any smart contract, whether you are going to run any function present inside the smart contract, all these things are technically called as transactions, right? And in Ethereum is a blockchain, right? In Ethereum, every transaction or smart contract operation requires computational power, right? It requires some computational power. So you can take an example of a car, right? So just like a car needs fuel to run, right? Or you can say if the car is running on CNG, right? Just like a car needs CNG gas to run, right? Ethereum transaction need gas to execute, right? And what is the meaning of transaction? Any kind of operation that you are going to do over Ethereum, correct? So all the operations, all the things, all the transactions that you are going to do over Ethereum blockchain, they require gas. Okay. In a nutshell, simply putting these things, gas is the fee that you have to pay to process any kind of transaction over Ethereum blockchain, right? So that is gas. You don't have to worry about this thing. I'm going to attach a resource link with the post. You can go through it over there. And it's very, very easy. Once you read it, you'll be able to understand what exactly is gas, what is transaction, why these things are required, right? It's very, very easy concept, guys. You don't have to worry. Now, once you run this, right, and once you save, see, there's a green tick mark over here, which is saying that yes, this smart contract has been successfully compiled, right? And see the compiler version, which is being used over here. It is 0.8.18, right? And okay, it's satisfying the compiler version that we have written for our smart contract, which is above 0.8.0, and it is obviously above 0.8.0, so it's working. But let's see if I set it to 7.4, right? And if I save it, okay, yes. See, you can see a warning and it is saying that compiler mismatch, right? So what do you have to do? Go back and use any version above 0.8.0, put this thing over here and save it. Once you do it, it will be perfectly fine. See, it's compiling right now. Yes, it's perfectly fine now, right? So your smart contract is ready. It is compiled. Now the next thing that you have to do is deploy. Okay. Now for deployment, guys, I told you deployment or any kind of operation that you are going to do over the blockchain, it is going to require some kind of gas amount, right? Or basically fee. Uh, if you want to, if it is going to take fee, obviously that fee is going to be associated with certain account, right? So whatever operation that you are going to do over the blockchain, it is going to be related to a certain account, and within that account, your what you can say, the token that is required for these transactions to go through on blockchain will be present. So on Ethereum, if you want to perform any kind of operation, you have to pay the fee, right? And fee has to be paid in Ether token, right? Ether is the token for Ethereum, or you can say Ether is the cryptocurrency for Ethereum, right? So you have to pay the fee amount in that particular currency only, right? And if you have to hold that currency, just like if you have to hold money, you need a bank account. Similarly, if you have to hold that currency, you need a Ethereum account, right? So we'll see Ethereum account and all in our upcoming sessions as well. You don't have to worry about that right now. You can just understand that by default, this remix is going to give you certain accounts, right? These are dummy accounts, and in each dummy account, you can see 100 ether present, right? 100 ether are present, so you don't have to worry about the funds, right? These are free funds for you for writing your smart contracts and testing. Now, forget about these things as of now, right? Because we are not going to dump down all the things in one lecture itself or in one video itself. Once you have selected any account, you can select any account randomly, right? Let's say I'm selecting the first one only and I'm clicking on deploy, right? Okay. So you can see that this particular, what you can say, smart contract has been deployed over the blockchain, and you can see some fee has been deducted. That's why it was earlier 100. Now it's 99.99. Correct. And this is the deployed instance of your contract, right? Now, if you click on this message button, right? See, one thing that you have to remember is anything that you are going to create using this public keyword, a getter function will be automatically created. What is a getter function? A function which will help you to get the current value of any variable or any array or anything that you are going to use, any key value pair that you are going to use. Okay, so if I click on this message, you can see hello world. This is the current thing, right? And let's say if I have to update this, you can just put this is my first interaction with blockchain. Simple. Update message. And if you again click on this message, you can see the message value has been updated, right? So that's how you have to go about and writing the smart contracts, right? Okay, perfect. Now let's do one thing. Let's create the smart contract that we want for our application. And for learning anything, the best application that you can create is To-Do app. I know you guys must have been bored of it, but to learn anything from scratch, to-do application is the best example. So let's say I want to create a to-do application, and I'll create a smart contract for that first, which is going to serve as the backend for us. Okay. So I'll just go over here and I'll say todo.sol, right? And the same thing that you have to do, just copy and paste these things, right? And close this, no worries. And you have to remove all this for now, right? And I'll name it as to do, right? So what we have done, we have declared a, or to do's, no worries about that. So what we have done, we have declared a contract right now. Now we'll write the logic for it, right? So first of all, your to-do application is going to have certain kind of description and a Boolean value, whether it is completed or not. So I'll just create a what you can say custom variable. Now in Solidity, you can also create custom variables, right? Or custom data types, not custom variables, my bad, custom data types. We know integer, we know string, we know Boolean, but you can create your own data types as well by the help of struct, right? So I'm going to create a task type data, a task data type, and this is going to have a string type of description, right? And it will have a bool type of completed or not, right? This is a status basically, right? And to store all the to-dos at one place, I'm going to take an array, right? So in order to declare an array, you can just say this is an array and this is a public array, right? And tasks, this is the name of the array. But what should be the data type of this array? Because you know Solidity is a statically typed language, so you have to tell specifically what will be the data type. And you are going to store this type of data inside it. That means you are going to store a task inside it. So the data type is going to be task. That's why, guys, I said that you can create custom data types as well in Solidity. So this is a task type of dynamic array because we are not at all, what you can say, specifying the length of the array, and it is public. So it is a state variable and the name of the variable is tasks. Now I will create a function to add a task, right? I'll say function add task. Perfect. It is going to take a string and it is going to be temporary. So I'll store it inside memory location and description, right? Obviously it should be public so that everyone can interact with it, right? For now, we are considering that everyone can interact, and I can just simply say that inside tasks array, you just have to push, right? Sorry, you just have to push what? You have to push a new task, right? You have to push a new task. And what description you are going to put inside it? You are going to put this particular description inside it, right? And initially the task status is going to be false, correct? So that's how you can add a task, as simple as that, right? Just like JavaScript, you can push what you can say elements inside array like this. Now, if you want to update the status of a task, what do you have to do? Right? Function, okay, and then complete task. Let's create a function like this. And obviously, in order to do that, you will need the index value, right? And what you can say, uint underscore index. Now, what is this uint? Uint basically means unsigned integer. When you have to store any kind of positive integer, you will store it inside unsigned integer data type, right? There is int data type as well, and that is not unsigned. Basically, you can store negative integers as well inside this, but an index value cannot be negative, right? It can never be negative. So that's why we are going to store uint, that means unsigned integer, and underscore index means this is again a temporary value. Now you will not put memory over here. You will not put memory over here because it is only required for string, you can say, right? For now, you can understand that it is only required for string. Although this is not the exact logic, we'll see what is the logic of using memory or any other kind of, let's say, storage location. But for now, for this particular example, you can understand that memory will be used with string data types, and you don't have to use any, what you can say, memory allocation with integers, right? Over here, this is going to be a public as well, right? Now, there's one thing that you need to do. you need to first check whether that index value or that index number is present inside the what you can say in your tasks array, right? So in order to do that, there is a statement, there is a what you can say control statement that you can use, which is called require, and it is present inbuilt inside your Solidity. You can just say if the index value that the what you can say the user is passing, who is basically calling this function, if it is less than the tasks dot length, right? If it is less than task dot length, only then you have to go through. Otherwise, you can just simply say task does not exist. So anything written beyond this require statement will only work. It is going to only work when this condition will satisfy. And if the condition is not getting satisfied, this message will be printed. Right? Now you just have to say tasks, right? At this particular index value, the completed status is going to set to be true, right? That's it. That's how you can basically update the value to true, right? And then you want something, or you want a function to remove the task as well. And similarly, in order to remove the task, you need to take a function, let's say remove task, and inside that function you will take again the index value, because if you don't have the index or the index value that or you don't have the index, will not be able to delete that particular task that you want to delete, which is present at that particular index, right? So what do you have to do? Take this index value, and then again you can say this is public, right? My bad, sorry. And then you can go over here and you can just simply say, again you have to check whether this is true or not, this particular control statement is true or not. So you just put the same thing, right? Once it is there, it will help you to check whether this particular index value falls within the context of tasks array or not. If not, then your message will be displayed. Then you can just run a loop, and loop is exactly like your JavaScript's loop. So unsigned integer, not unit, my bad, unsigned integer, and it should start from index, right? Now my logic is a bit different over here, and you'll understand this when you will go deeper into Solidity, right? Just now, just focus on the logic that I'm going to write over here. What I'm doing, I am trying to shift that particular index value at the end of the array. So whatever is present at that particular index value, I will push it, or I will shift it at the end of the array, and then I'll pop it, because I know pop deletes from the end. So I'll shift that particular value at the end, and then I'll pop it, right? I'll tell you why we do it in the next session, in the next video. Basically, you don't have to worry about it. But for now, just go along with this logic, right? So how can I do that? I can just run a loop till tasks, sorry, my bad, dot length -1. Now, why length -1? Because I don't want to run it till the last index, because at the last position, I want to put that index value, right? And then this thing, obviously, the increment. And over here, you can just simply say that tasks present at ith value shifted to i+1 value. Basically, I'm shifting it one index ahead, right? Once it is at the last index, right? What will you do? Just tasks dot pop. It will remove that particular task, right? That's it. Now you can basically create a function to get all the tasks as well. It is very simple. You can just say function get tasks, right? And it is not going to take any parameter or any argument. Public view returns. Now, what exactly is the meaning of this? It is a public variable. That means it can be called from anywhere, even outside the contract. What is view? View basically means it is not basically changing anything, or it is not going to change any state of your blockchain, or it is not going to change any state variable. It is not going to update any state variable, right? It is just viewing. This is basically implemented to those functions that are just doing read operations, right? And returns basically means this is a function that is going to return something. Now, what it is going to return? It is going to return an array, right? What kind of array? Task data type array, right? And then obviously this is going to be in memory only, because this is just a temporary variable that we have taken. Again, you can see I'm using it on string, I'm using it on array, right? So you kind of get now on what kind of data types this memory location will be used. But still, if you're not getting it, don't worry, we'll clear this out in the next video, right? And then over here, you can just simply say return tasks, right? Perfect. Okay. Now, once you save it, as soon as you save it, you can see it is ready to be deployed because compilation is successful. Now you can just directly go to deploy, right? Let me remove all this. Deploy this, and you can see this is going to be successfully deployed. And again, it is going to be deployed from the same account, right? Now, this is our contract. Now we should test it, right? Let's see what tasks do we have on the blockchain right now. If I just click on this get tasks, nothing is there, an empty array, right? And you can see the, what you can say, you can see the type of it as well, string and bool, right? When you create this struct, right, internally it is going to be stored as a tuple. Okay, some people call it tuple, some people call it tuple, but I prefer to call it tuple only, right? So right now it is empty. Okay, let's say I want to add a task. I'll say go to gym, right? Click on this. As soon as I do it and click on get tasks, you can see there is a task over here, go to gym and false, right? And if I click on this tasks, what you can say, array, because I told you that this is a public variable, so a getter function will already be created for it, right? And if I say at 0, so it will give me the task which is present at the 0th index. Go to gym is the description and completed as false. Now let's say if I add one more, go to gym and go to market, for example. My bad. Go to market, add task. Okay. And if I want to get from the first index, you can see go to market is there. And if I click on get tasks, it is going to give me all the tasks, right? Now let's say if I want to update any one task to be completed, I can just say one and complete task, right? And if I go and get all the tasks, you can see that go to market is true because it was present at the first index and it has been updated to true. Perfect, right? Let's add one more. I'll say go to gym, go to market, and let's say eat. Anything random. Add task, right? Now get tasks, and you can see that this eat is present at the second index. You can verify from here, right? And let's say you want to delete this, right? You can just put the second index, remove tasks, remove task basically. And when you get the task, you are not going to get that eat task that we have just created. And if you click on this, see, it is not going to work and it will say the transaction has been reverted to the initial state. So whenever the transaction is not going to be completed, it is going to be reverted back to you, right? So it is because of this particular require statement, right? Which is just checking that this particular index value does not exist within the tasks, right? So it will say task does not exist, right? And it is going to give you this particular error, right? So that's how you can create a basic, what you can say, smart contract. And this is a very basic smart contract. There's one more thing, guys. If you're not able to understand this, you can just copy this up and click on this chatbot. Now, this is just like Chat GPT only, a generative AI tool. You can just put it over here and say, make me understand each and every line of this smart contract, right? Let me just put this correctly and hit enter. Now it is going to help you in understanding the entire smart contract. It is going to help you why exactly you have defined it in public state, why exactly you are defining this license identifier, why exactly you are defining pragma solidity, right? So it is going to tell you each and everything. And by the help of this generative AI, right, you can create your own smart contracts as well. It is going to give you suggestions, right? But you should know the basics as well. And for that, you have to go through the documentation that I have attached with the post. And that's all for today, guys. In the next session, we'll understand how to deploy this particular smart contract over Ethereum blockchain. And I know you are going to have a lot of questions. So drop down your questions inside the in the comment section. I'll be happy to respond to you over there. Thank you very much, guys. That's all for today.